Hi, I'm Miss Hearn. Let's get started. In this video, we're going to talk about the basics of probability. So probability is concerned with random phenomenon. It's a way of measuring the likelihood of an event occurring. In probability, any observation or measurement of a random phenomenon is considered an experiment. So it's not necessarily an experiment like you do in the laboratory. The possible results of the experiment are called outcomes, and the set of all possible outcomes is called the sample space. Usually we're interested in some particular collection of the possible outcomes. Any such subset of the sample space is called an event. So for example, the experiment might be rolling a 6-sided die one time. The possible results of that would be things like rolling a 5. These are called outcomes. So rolling a 5 is an example of an outcome. The set of all possible outcomes is called the sample space. So that would be the whole set, 1, 2, 3, 4, 5, 6. And the event that we're interested in might be something like rolling an odd number, which would include the individual outcomes 1, 3, and 5. Here's an example that you're probably familiar with. If a single fair coin is tossed, find the probability that it will land heads up. If it's a fair coin, then it's equally likely to land on heads as tails. In probability, we would say that the sample space consists of heads and tails. The event whose probability we're looking for is that heads lands on top, facing up. So the probability of heads, you probably know, is 1/2. You might state it as 50% or 50-50, but in probability, we like to think of it in the fractional form, 1/2. And you can think of that as the number of favorable outcomes, the number of ways that the event E can occur, divided by the total number of possible outcomes in the entire sample space S. Notice that we didn't actually flip a coin in order to come to this conclusion. So the kind of probability we're talking about is theoretical probability. Here's another example. Assume that the spinner on the right cannot land on a line. What's the probability that the spinner will land on red or blue? Let's start with red. The sample space contains all 10 possible regions where the spinner could land that are equally sized, so there's an equal chance of any one of them happening. So the number of items in the sample space is 10. Now, the number of ways that a red can occur is 3. So the probability of getting a red, which we would denote as P for probability, parentheses E, where E represents the event that you got a red, would be the number of favorable outcomes, the 3 reds, divided by the total number of outcomes, 10. And the number of ways to get a blue is 2, so the probability of getting a blue is 2/10. Although we should reduce all fractions to lowest terms, so dividing the numerator and denominator by 2, we get 1/5. Each of these examples demonstrates the definition of theoretical probability. If all outcomes in a sample space S are equally likely and E is an event within that sample space, then the theoretical probability of the event E is given by probability of E is the number of favorable outcomes divided by the total number of outcomes, N of E over N of S. Here's another example. There are 2,598,960 possible hands in poker. I should specify this is 5 card hands. If there are 36 possible ways to have a straight flush, find the probability of being dealt a straight flush. Well, I don't know if you're familiar with poker, but a straight flush means that the cards are in numerical order like 5, 6, 7, 8, 9, and flush meaning they are all the same suit, like all hearts. So you can imagine it's not very likely to get dealt those 5 cards that are numerically in the same order and all come from the same suit. And so you can see, in fact, exactly what the measure of that likelihood is. The probability of a straight flush is 36 divided by 2,598,960. So there's only a 0.0000139 chance of getting a straight flush in a card game. Here's another example. A school has 820 male students and 835 female students. If a student from the school is selected at random, what's the probability that the student would be a female? So according to the definition of theoretical probability, you have to divide the number of favorable outcomes by the total number of outcomes. So imagine that you're putting the names of these students in a hat. We want to know what's the probability of picking one female out of that list. Well, how many names are going to be in the hat? It's going to be the sum of the 820 males plus the 835 females. So that's going to be our total possibilities, the sum of those two numbers. And the number of favorable outcomes will be 835. Female students divided by total number of students, 835 divided by 820 plus 835. You have to add in the denominator first, and 835 divided by 1,655 is going to give you 0.505 if you want to write it in decimal form. Sometimes we have to use some of our counting methods in order to calculate a probability. So here's an example of that kind. A business owner calls the phone company to set up a service for her new store. She hopes to get a phone number in her area code and prefix with the last 4 digits spelling out Jazz, J-A-Z-Z, or 5299. If randomly assigned a phone number, what's the probability that this is the case? So in order to calculate this probability, we need to know the number of phone numbers that would be favorable out of the total number possible. Well, there's only one favorable outcome, but using counting methods, we can count how many 4-digit prefixes are possible. There are 4 digits and there are 10 possibilities for each. So 10 times 10 times 10 times 10 is 10,000 different phone numbers that are possible. Our business owner only wants one of them. So that means that there is a 1 in 10,000 chance of getting the phone number she wants. I hope you found the video helpful. If you did, please give it a thumbs up. That will help other students to find the video. The next video is about experimental probability.